Good morning, everybody. My name's Jason Fox. I'm the Senior Technical Manager of the FIWARE Foundation, and the subject of today's FIWARE webinar is Advanced NGSI-LD Registrations. So let's see what we're going to be covering today. There are multiple types of registration within NGSI-LD, and specifically NGSI-LD. NGSI v2 has only got the one. So we're going to review the types of registration which are available and propose reasonable use cases for each one. There are also, particularly when you're talking about data spaces, there are multiple problems which need to be overcome. So we'll look at how to avoid putting too much traffic into your data space, how to avoid loops, and also various elements which are in the NGSI-LD specification as optional within the context broker functionality, but obviously are there to try and improve the response time of the system. Now, when we get to the demo, some of my endpoints are deliberately not very responsive. It's not the context broker which is causing the issue. It's my little forwarder, because you think about data spaces. You are getting a holistic overview of what everybody knows, and of course you've got no control over somebody else's um, hardware, or and you don't know if they're online or whatever. So there needs to be some sort of way to get as much data as is currently available on the now. So things like partial failures and timeouts will also be discussed. Now, in the most recent NGSI-LD specification, there's been an extension added for linked entity retrieval, which is a little bit like a registration, except that it's all getting multiple entities from one particular context broker. Again, in theory, it could be distributed as well. So we'll cover that as new functionality. So let's get on with the show. There are 4 operational modes within NGSI-LD, and they are basically divided into 2 halves. There are additive registrations and proxied registrations. Now, the important point about an additive registration is that a context broker itself is permitted to hold data about entities. So I could hold information about buildings or farm animals or whatever, but I can also get other information from elsewhere. So in the scenario we're dealing with today, we are having a farmer who's also going to get information from a contractor, a vet, or whatever. But it's not just from the vet; it's from all of the participants coming together and giving an overview of what's happening. This is the standard registration format in NGSI-LD. Because it's collaborative and it means that you get the overall viewpoint, what the farmer knows, what the vet knows, what the labourer knows, and so on and so forth. Now, there is an alternative additive registration. This is probably the least used of the registration types, called an auxiliary registration. This is a case where what I know as the context broker is more important than what you know. So if I've already got data about the weather, for example, then I will use that in preference to asking maybe a more expensive or a slower resource to give me the information which I've already got. So with an auxiliary registration, the data in an auxiliary registration never overrides the data which you can get from the context broker you are calling. Now, the alternative to the additive registrations is so-called proxied registrations. Once again, there are 2 types, and in this case, the context broker itself is not allowed to hold information about those entities. All the data comes from elsewhere. Now, the classic example of this is the one which was used for NGSI v2, which is obviously for isolated systems. This is so-called exclusive as opposed to inclusive registration. And in this case, all the data is coming from somewhere else. So a good example of this would be, let's say you've got devices in the field where you really want to get the data from those devices. Well, in that case, you could have an exclusive registration to say, yes, I want to get the very, very latest information every single time. Context broker knows about these values, but hasn't got it held in itself, is not following the cannot follow a temporal timeline for it. Every single time you request it, you get it. Another good example for an exclusive registration is actuations, because if you really want to do something in the field, then that is like turn your water sprinkler on. Then you want to do change the state of the digital twin, then change the real world. Well, that's a good way of doing it. You can do it using a subscription, of course, but in this case, the only place where the actual stuff is held is the device further down. Now, there is another type of proxy registration, and that is the redirect registration. This is quite simple, really. It's a simple forwarder, but you can imagine there's a system where I want to have my data in multiple context brokers. I want to have my animals in my farmer's context broker. I want to have my buildings in a separate context broker. I want to keep my payroll system separate from something else. Or indeed, if you're talking about something with security implications, I want to keep the health information for different people in different context brokers or different tenants of different context brokers. In this case, you can set up a redirect registration, which means that the context broker at the top of the hierarchy has got no data. The context broker at the top just says, well, whenever you ask for animals, I'll ask someone else. And therefore, whenever I do a post to create an animal, let's say, it will say, I can't deal with this. I need to push this down further in the system. This allows us to have a hierarchy where you have one front context broker, which potentially does your JSON-LD expansion compaction operations, and you could have something behind the scenes, which could be some sort of proxy, some sort of connection to a database or something like that. You don't know. It just offers the data in an NGSI-LD format. Now, this is the scenario which will be covered, showing the different parts of the NGSI-LD smart farm. And it's a system of systems, because each of the elements within this hierarchy it's basically its own little application. I'm using the farm management information system as just a display. It doesn't do anything. It's got, maybe it's got some farm buildings or stuff like that, but the information is actually coming from the attached farmer's context broker. So the farmer's context broker obviously wants to get this information about the animals holistically. So it's got they in turn have got multiple information about animals born on the farm, animals requiring care on the farm, and obviously devices like temperature gauges, soil sensors, or animal collars. So in this case, the farmer has data themselves, but they also can get data from the veterinary contractor to add them together. That is an example of a inclusive federation. The farmer also might want to do things on the farm with an IoT agent. So that would be an exclusive actuation. Now, potentially we could have a hierarchy which would involve many more systems in this scenario. The demo doesn't cover them directly, but you could imagine, for example, that the vet and the contract labourer require medical information for the animals. Well, because the interfaces of NGSI are designed to return the data, whether it's held directly in the context broker or further down the hierarchy, it won't matter whether I've got that data in the vet or I've got the data in a medical veterinary system, which is further down the hierarchy. It will just give you back the data as required. Similarly, we could add in additional information to make better decisions, say the weather forecast or payroll information or whatever. So we've got multiple ways of getting this information out of the system, and each one of them have got a reasonable use. The minimal version of a registration is the elements in bold, because there are various defaults which are applied. So the default mode is inclusive, and it's so-called federation ops. Federation ops is read-only, because you expect that the system is running itself. They do the usual CRUD stuff, but I want to have access to some of their information. The mode is inclusive, because we're trying to get, by default, we're trying to get hold of all the information so that we can make a good decision. The required parts are information and endpoint. Endpoint may or may not have an additional port to it, but it's actually, where's this context broker hiding? And the information, which actually can be expanded, is saying, well, what are these entities we've got? You could be looking for entities of a certain type, or you could be looking for a specific entity, like an ID, or you could use an ID list, or you could have some sort of regex pattern. Furthermore, by default, when you do make a registration, it is registration for all the information which is held. You will notice that it is possible to restrict a registration down to certain property names or relationship names. And this is important when you start looking at things like the attributes endpoint, because at the moment we're just saying anything you've got. I don't know where it's come, what you've got, but tell me everything you've got, and we'll get hold of the information required. There are several ways which you could have a problem when you've got a hierarchy of brokers which may be talking amongst themselves. It is possible you might have context broker A talking to context broker B, which contacts context broker C, which then contacts context broker A again. Now that's obviously going to be an infinite loop. So there are this thing called context source alias, which can come from the info source identity endpoint, which will say, as far as I'm concerned, this source has got this unique ID vet. Well, that could well be based on a tenant, or it could be a default. It could be the default tenant. But this information is used to avoid looping. When you get looping, the context broker checks the headers it receives to say, it's already been through the following context brokers, and if it's already found itself on the list, it doesn't bother returning any more data. Now, there is a header which the context broker should supply, which says, I am looping, which is the NGSI-LD warning header, which should be passed back up to the end user if such one of these is found. Now, obviously, in the case where you have context broker A registered to context broker B and context broker B registered back to context broker A, and that's the only data you've got, you should actually get back a proper error code. But in most cases, it will just silently ignore requests for loopy data, because obviously the way that the hierarchy is registered could be out of your control. You've got no, the vet doesn't have access to the contractors' registrations. They're all separate entities within the system. So it needs to be able to warn you that something's going wrong, but it's not going to just say this is an error message unless it's a very, very fatal error message. There are additional elements which can be used to reduce the amount of traffic on the system. This is mainly the refresh rate and the management. Refresh rate management are may be used by context brokers. They're not always used by context brokers. But the refresh rate, for example, is saying, I've got an endpoint. It only updates once every day or whatever. So you don't need to keep asking me all the information. You can cache it if you wish. If you use refresh rate, you need to use the ISO 8601 duration format. Similarly to the way that the timestamps are all ISO 8601 timestamps. This is a format which says P for period, and then goes down through days, hours, minutes, down to milliseconds, and you don't need to have all of the elements in there. You just need to have the elements which are necessary. So the refresh rate on screen at the moment is saying once a week, once every 7 days, but you can go down to much lower elements. Similarly, if you look at management, there is a flag which is available, which it says local equals true, which means that I want to get data from a context broker, but I don't want it to call its registrations down the line. It will just ignore registrations. That is obviously useful to avoid hierarchy. So if you have one of these loop things, then you can say just get the data which is you've got, not the data which I already know about from other situations. Now there are also two more elements which may be useful. One is the timeout. How long do we want to actually send the request out before we say, you know, you're not there. We're not going to get any data from there. You'll find that context brokers have got a default timeout. It's possible that an endpoint won't respond, and actually, with the demo, I've deliberately got some flaky responses just to show what happens in the case that a resource doesn't respond and it's a get, which is the most obvious situation. You just don't have the information which is available. That's it. It's just a case of what I currently know about the world is from broker 1, broker 2, broker 3, whatever. Once again, it is possible that a context broker may wish to cache information. If it says I'm allowed to get hold of this information, fine. And similarly, when it errors, maybe it doesn't want to contact that particular context broker for a while because it's offline. So what's the point of sending errors which come through? In the case where there are error responses, once again, the NGSI-LD warning header should tell you, yes, this one is a constant error, this one is not online at the moment, it's a timeout, whatever. When you actually do updates, then updates, you can go down through the hierarchy of context brokers. You could have a redirect, which then does a federation, which then pushes data to every context broker if they are offering those endpoints. Now, in the case that there's only one context broker which is connected and only one context broker which is failing, you would get a bad gateway saying, this proxy it doesn't exist. However, the most annoying response you will get will be a partial success, which means that some of your context brokers, like your local one or some of your registrants, successfully got the information, some of them didn't, which means you've now got a more inconsistent state. In that case, there will obviously be an error response and a success response. And furthermore, you can work out, that particular context broker has failed to do something. So let's have a quick look at the demo. I've already started up my farm, and at the moment you can see that I've got some farm buildings as is usual within this system, because my FOIS has got some entities in there, but at the moment I've got no data within the system. Let's move this across slightly. If I go to my farmer's context broker, well, I'm actually within this particular demo, I'm using tenants to separate my data. But if I look at my farmer has actually already got some cows and pigs within the system, so I can actually get hold of the cow, or I can attempt to get hold of information about a cow. However, if I go back to the overall context broker, the FMIS, I'm not using a tenant. And if I try and get hold of some entities at the moment, it will say there's nothing there. So if I create a registration, and this is the registration, I can register multiple entities. And the first one we're going to do is a redirect, which has got redirect ops, which means every single request which we do, which would also include things like a post or a patch or whatever, would go to my farmer. Having done that, I get a 201 created, as you would expect. And now if I get my farm animals from FMIS, if my farmer context broker is now responding, I get back data. If I now refresh my my application, you can see I've got a series of animals up on screen saying this is what is going on. Now you can obviously check the information here to see what's available. When you check registrations, you need to provide some information about what sort of registrations you're after, or we'll set that as for animals. So this is what we've got for animals, or animals and agri-parcel. If I put something which didn't exist, it wouldn't be in there. Now there are other animals which are available for my vet. You can see the vet is here, and the vet is dealing with animals which require treatment. Or newborn animals. You can see there's some additional animals here. If I were to do a registration on the federative registration onto from the farmer's context broker, once again it's created and then refresh, you can see I've now got some additional animals on the farm, which are the small newborn calves and the young. Also, there are animals which require treatment. So, Beanie the bull needs to have his hooves checked. If you have a look at the details of what's coming through, you'll notice that there is the observed at element here. Observed at is useful when you're putting in any data, not only for time series information, but also to make sure you get the appropriate information coming through, the most recent. So once again, if we look at our contractor who's now checked for those hooves, have I got the contractor? Yeah, on that particular cow. Once again, I can look for the comment. You can see once the contractor has actually checked the hooves and the bull is okay. Now, if I were to register the contractor as well, we're going to have some sort of conflicting data, because the vet says check the hooves, and the contractor says I have checked the hooves. Now, because the contractor's observed that date wins, assuming that that both context brokers are responding, it will say checked hooves, bull is okay, and it will show you that it's got the updated observed at, the later observed at within the system. When you are looking at what data is available, there's this /types endpoint, which says this is the sort of entities which are either held within my system or available within my system. If you remember, I just set up a redirect on the FMIS. So they haven't actually got any animals, but they know about animals. And this can be useful to work out what sort of entities are available, and you can get more details. So let's say we wanted to know more about buildings. Let's say we could put /buildings at the end of that. Similarly, if you look at you can also look at this on the attribute level. Once again, I'm just looking at the attributes for the FMIS. This is all of the attributes that the FMIS directly knows about. And you notice it only knows about buildings. It doesn't know about animals, because the animals all it knows about animals is the type of the animal. It's not requesting further down. You can get more detail about a specific type. So now going on to the farmer. The farmer has got the following attributes which are available, and it also says, this is a property, this is attribute property, there's a vocab property, this is a relationship, and it also gives you the number of entities which exist within the system. And once again, you can get even more details about the attributes themselves by doing attribute slash whatever the name of the attribute is. Obviously, this undergoes the standard expansion compaction. But when you find out what is a species, it will actually say, well, actually, within my system, the long name is whatever I've set up as the data model for my species. It's only available on animals, and it's usually a property. This should give information as necessary. So yeah, these are the standard endpoints. You can see you can get things like entity info list or attribute list to get more information about various attributes. So you can basically it's metadata about the system itself. Now, within the latest NGSI-LD specification, that's 181, there is an ability to retrieve multiple entities at once which are related to each other. Yeah, you're all familiar with the idea of relationships. So you have an entity, which is the linking entity, and it has a relationship to another entity and a relationship to a second entity, and they can go down a hierarchy. And you might want to get the information about both the baseline one, the linking entity, and all the various links on the chain. Registrations place an attribute directly within the entity. So if you have a registration on the temperature attribute saying it's coming from another registered location, different context broker, when you retrieve in this case, the agri parcel, it will get a temperature. Whereas linked entity doesn't do this directly on properties, it uses relationships. So the difference here is that instead of having the piece of land has a temperature, you'd say the piece of land has a device, and that device has got a temperature. Now, it's possible to get both of these if you're using an older system or one which doesn't support this part of the modern specification. You can do this using multiple requests. Get the piece of land, read through, it's got a device, and make a second request. But the latest specification will do both of these parts for you within the context broker. Here's the use case which we can deal with, is that you could have a piece of land, an agri parcel, and that would have properties of its own, like soil type, crop type, whatever. But it could also have information which could be coming from other entities. So you might want to get both the weather you're observing and the weather that you're expecting to get later on. Now, this is useful because there are already data models for weather observed and weather forecast. And because both of them are able to get hold of something like temperature, you don't need to have different attributes called observed temperature and forecasted temperature. You can use the attribute names which you would expect. So this helps with the ontology. So we can get hold of a piece of land and its current state from its device and its current state from expected state from a weather forecast in one go. This is the way you'd set up the linking entity. The linking entity has got obviously a couple of relationships in there, but those relationships should have a non-reified attribute called object type. This makes life easier to retrieve data further down the line, and you can see that okay, when I follow this node in the knowledge graph, I would expect to find at the end of the prediction a weather forecast, or at the end of the observation the other. Obviously, object type is under the hood is actually an at vocab, so you'd expect that to expand if you were placing a appropriate context, and you can change that because it's just the same as any ordinary entity type. You obviously can have normal properties as well. You can have normal relationships which don't necessarily have something at the end. If it doesn't find it, fine, not a problem. But the object type is useful for going further down the hierarchy. And of course, the sub-entities, the linked entities, are just ordinary entities. So they've got properties, fine. So that's just, basically FIWARE 101. You've got nothing unusual there. If you use join inline, you will get back the entities and the linked entities. And this is embedding the linked entity, like the weather forecast, inside the response. It's fairly obvious that you're going to have it, if you have an observation, it's going to have the weather observed inside it. You could, in theory, have the same entity multiple places if it's linked, if the relationship is in multiple places. If you had an array, same sort of thing. You'd expect to have an array. The alternative to inline is flat, and this is where instead of getting entity data inside the entities, you will get effectively the format which you would use for a batch upsert. So every entity is at the top end of the array. So you've got all the information back in a standard format. You've got all your each entity is a separate entity, and then you can obviously use this information to make some sort of inference. In the case that there was multiple relationships to the same entity, it would only appear once in this array. You wouldn't get it more than once, so they're merged together. It's not just normalized format as you'd expect. You would able to use this for concise as well. In the case of concise, you just drop the use of type equals relationship, type equals property, type equals whatever. It is sufficient for this response that you've got an object, and the object obviously has got an entity type and entity as if it's metadata. The simplified format, of course, is lossy, but it does give you back all the information within the object itself. So in this case, if I have a prediction, you'd get, which is a relationship. If I don't use join, I'll just get the ID of the relationship, which is the weather forecast. But if I do use inline join, I'll get all the data for that entity just as attributes. So you can see that you can, in this one, you've got things like prediction.wind speed would be sufficient. Now, if by default, you'll get all the attributes back. But of course, you can use things like attrs or pick or omit to reduce the response to a much simpler format. So if you're only interested in humidity or temperature or wind speed or whatever, you just put curly brackets around the elements inside the linked entity just to get that attribute back. The query language has been expanded to cover this information as well. So you can have join inline or flat. The default join level is only 1 because this can be a very expensive operation. It is easier if you are just having spreading your attributes, your data within one context broker, because then that's basically just one database call. But in theory, you could place it into multiple context brokers, like we were doing for the registration. This is once again we have problems by looping potentially. So when you pass information onto the next context broker, it will also tell you about other entities it's already retrieved, so only needed elsewhere. Queue parameter works just the same way um, as the pick and omit. Again, curly brackets. So if you want to get if you want to do a query on the humidity of a sensor which is within a type weather station, then it's going to be curly brackets around humidity. You can help the query speed up if you can also provide the object type, because this is obviously information which is held in the context broker, and perhaps more importantly is required if you're trying to do registrations. If you remember, the animal registration was we were registering entities of type animal. Same thing here. We could get the devices elsewhere if necessary. This is just it's not required, but it is something which makes retrieval quicker. So it's definitely best practice if you know what the entity actually is. And that is the basis of this presentation. Okay, so thank you very much for listening for this presentation for registrations and linked entities. And I hope you have a good rest of your day.